The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Kilauea volcano update. We'll touch on Mauna Loa a little bit as well, and since things are going pretty much as usual to the pattern we've seen in the last few months on Kilauea Summit, we will spend a little time looking back at 2018 and honoring the residents of Kapoho who 4 years ago this week had their communities overrun. So we'll talk about that. We'll talk about the lava delta, where the lava went into the ocean. It turns out in the end, 62% of all the lava of that eruption went into the ocean. We'll talk about that, the EV Nautilus surveys, the underwater bathymetry and all of that. We'll take your questions in the chat as usual. Dana will lead a discussion in the chat as usual. We'll bring some on our live discussion as well. And let us know if you have any issues with our audio or video, and we'll try to keep things on track here. All right, anything to start off with, Dane?
No, I think that's good. Definitely Kapoho is going to be hard to cover, but, we've done it before, and there's a lot of, emotions for people that were down there that come up this time of year, and, we'll try and go through, what we remember and what's come out since then, because it's always a learning process each year, what comes out and how we can refine it a little bit further.
For sure, yeah. We're hoping to honor those people by remembering the important things, and especially the areas where we can use a little improvement, and the things that still stick with us, vividly 4 years on, right? And that kind of where we can come at it. All right, so that being said, we will start with our Kilauea weekly summary. And here we have one of the more recent videos from the USGS. This is zoomed into that West Vent Pond area. The West Vent is actually more off in that direction, off of this image. But you can see there's an opening, some pathway that comes down. It's mostly crusted over. And then there's a lava falls right here. This lava's pouring down and in to this pond. You can see spattering on the edges. There's the crust is formed on top of it here with this silvery gray stuff that's spreading apart here with this orange in between, right? It shows you how thin that actually is, just a few millimeters. And the whole thing is basically not filling in and overflowing. It's draining down and through and out to the lava lake, off in that direction, probably from this perspective. And so that's just a little clip, and we'll get to this a little more when we review the other part of the video here. But I want to start you guys off with one of the more unique views we've had of the volcano in the past few weeks here. So that being said, we'll move on to our F1 thermal camera, also courtesy of the USGS Hawaiian Volcano Observatory. And this is showing us our persistent lava lake. So this is the camera's closer to this spot here on the western side of the crater floor, which is why it's taking up so much of the view here. Everything is really, I suppose, blown up, right? It's enlarged in the foreground here. So we've heard that this lava lake is about 2% of the entire lake surface, a little less than that probably by now. And you can see it's got the active circulation of lava through there as well. Last week when we were doing our update, we were seeing this overflow that spilled over from this direction. So you can see that the end of that catches in our time lapse here. And otherwise, you see a lot of ooze flows all around the perimeter of the crater floor, as we've been seeing for a while now. They do seem like they're a little more active this past week, maybe the last couple weeks than possibly the week before that. But we'll have to await some more statistics from the USGS to really put our finger on if there's any change in eruption rate or anything like that. Hard to tell just from this visual, but visually it does look like there is a good amount of flow coming in. So I would say that of the range we've seen recently, we're probably on a higher end of it, but it doesn't seem like it's that high or anything crazy, right? So business as usual, no increased threat. The main threat still being the gas, which we'll cover in a little bit as well. So that's our usual at the lava lake. Here's our West Vent Pond that we were just zoomed in on with our earlier opening shot, and the rest of the West Vent complex here. And you see some fuming vents at the top and kind of flows leaking out, oozing up from the bottom more so than coming out of those vents right now. And there's that area that's brighter on the side right there. If I can maybe zoom it in for you guys, you might have a chance to see it. There's the little lava falls on the side, and then the pond itself, something like that. That's what we're seeing here. Okay, so this view's got clipped off a little bit of the sides. The lava's filling in off the screen off that way, and off the screen off that way. You can see it's persistent all the way around off the screen that way perhaps as well. So we'll turn to our, we'll check in with our last 24 hours because that gives us a little bit more resolution. It's a little bit slowed down as well. So you can see still having the ooze flows around the perimeter, although perhaps a little less here towards the end. And if you look more closely, if I zoom it in on the lava lake surface right here, you'll see that really within the last maybe 12 hours or so, the lava lake level has begun to drop rapidly. There you can start to see some of these exposed crater walls right below there. Right? And maybe you can look at this little isthmus, this little connection to the southeast pit, and see its walls get exposed as well. So that's what this just looks a little more purple, but there's a little gap right there, and that's the story today as we broadcast right now, is that we're having a drop in the lava level. But it still seems to be circulating and persistent within that active pond right there. Okay, now we'll move on to our KW camera, which is a little bit wider view here. You can see the edge of the lava all the way from here, and all the way from here. And you can see at nighttime, the ooze flows around the perimeter as well. Very blown out brightness from the lava lake right there in the center. And that's the last 24 hours, so you can see it's pretty similar, and it's hard to tell exactly when it flips, but it might be a little bit less tonight if the pattern continues of the drop of pressure perhaps that we're seeing corresponding to the drop in lava lake in the persistent area right in here. So we'll look at the whole last week. Here's a KW camera for the whole last week. I'll zoom in a little bit. Trying to get it all on screen here, but you can see that there's been flows on this northern downdrop block overflow area right here. And there's also like a northwest one over here that we can't quite see, but seems to be active nearby there as well. And pretty much the same as everything else we've seen, right? So one thing we've been using this camera for in recent weeks as well is looking at this eastern side of the crater floor, because this is the area that can be seen from the Uikahuna overlook in the north side of the caldera. So we will transition into our lava viewing with this view right here, and just point out that there's been lots of lava flows. Let's zoom it in a little bit over here. A little bit more, I should say, right? So this area right in here has had plenty of lava flows over the last week, so it seems like it's been pretty good viewing over there from the north as well. Not as much in the middle central part of the eastern crater floor, right over here. But you do see one big ooze up flow come up at the back on that eastern wall and the back wall from this point of view. And there it is right there. Moving on, keep it efficient today. We'll look from the west. This is the B1 camera, so that persistent lake's at the far side now. It's now really compressed in the whole view, and enlarged is this foreground here of this eastern side of the crater floor. And you can see at the bottom this big ooze up flow that comes in at the end of the sequence here, right? And more of that down drop block overflow to the northeast is more over here off the camera in that direction. But it is cool to see from different angles this ooze up pattern, and you see, you know, kind of all around, not continuous all the way around, but it pops up here and it pops up here and it pops up here, pops up over here and over here, and so on and so forth. And we'll see the B1 camera once again in a little bit, but first we'll keep talking about the lava viewing. And just to remind you guys, this is a view taken from Uikahuna overlook. We're looking through a little bit of a gap. You can see that eastern crater floor. So there is those two little spatter cones putting out lots of fume, and you can see you can't see the main active vent off screen to the right that way, but you can see this eastern crater floor a little bit, right? So that would be where the viewing would be. So in our park map, here's Kilauea caldera. There's the pit with the lava in it being in here. And we're talking about the spot that's more or less right in here, just to the east of Uikahuna Park at the former Jagger Museum, and then walk back towards Kilauea Overlook. And that's what we're looking at right there. I can't really get it any bigger here. So that's the overlook that we've been mentioning for a while. Kupina'ipale Waldron's Ledge over here on the east. Also, we'll bring you guys footage of that hopefully next week. And I've been saying that for a while, but I'm challenged to get out there, so the right time. Keep trying. And as usual, Kanakakoi Overlook over here in the south, where you get the main viewing and the most direct view of the active lava lake and the vent itself. All right, there's so much happening across the whole crater floor that it's really getting better from everywhere, but we're just highlighting these spots as usual. And to give you a reminder of what it was like from Kanakakoi, here's a little bit older footage of that wider angle view of Kanakakoi. Mauna Loa on a background back over here. And you can see there's that whole crater floor right in there. I'm going to try to zoom it in some more for you guys. And so the main active lava lake is just that little bit right in there. But if you have a good telescope or binoculars or telephoto lens, that kind of thing, you can really get some nice views. The thing now is there's so much happening, you can zoom into over here, or zoom into an overflow over here, or zoom into an overflow over here, or so on and so forth. You can kind of, depending on what moment you happen to be there, you'll see the activity at different areas on the crater floor, which is really cool. A unique experience for every visitor.
I got a question here for you. Fits in. Jason says he doesn't understand. Is the lava ooze out caused by the cool lava cap lifting and separating from the wall? Or is it more from a pressure underneath, more of a pressure burst?
Yeah, it's it kind of both, right? I mean, it is exactly that that hardened crust is lifting up, and we'll see that here shortly with that USGS time lapse of the from the B1 camera, how that crust has been lifting up, and they're using the term endogenic, where it's happening all underground and basically filling from below. And so there's enough pressure to actually put it in below there and erupt into that submerged lava lake / surface-like chamber, reservoir, yeah, something like that, to keep pushing it up and out. Yeah, and to do so around the entire perimeter, pretty much all the time, right? If you speed it up, it's basically all the way around. It's popping up and oozing out. Yeah, that seems to be the main way the crater floor is growing right now, is lifting that center and oozing out the sides. Right, everything we see going into that active lake is just circulating back down and back under the crust as well, and doesn't really spill over from there very often. Right, sometimes it does, and it'll pave that upper part, but for the most part, it's lifting from below. Right, so there's enough pressure to do that, and interesting along those lines, and we'll get to this here as well, but interesting that when the pressure goes down, like in deflation inflation as we're seeing now, that the lava level is dropping, but it's not stopping all the way anywhere, right? So there's still enough pressure even during the lower pressure to keep that active lake circulating at present. So cool to see that. It's not how it always has been, right? We saw an era of a few months there where every time the deflation happened, the lava would basically not be visible on the surface anymore for sometimes 2-3 days. So it's been a while since that. Yeah, good question. Thanks, Jason, for that. All right, so let us continue with the viewing report, and that's the kind of like a Koi view. We don't have direct footage this week, but we'll, as usual, use the S1 camera as a proxy for what you can see from that direction. Right, we're having shown you guys that actual view just now. So there is a persistent lava lake. There is that southeast pit, and sometimes you can see little falls of lava right in there, and unless the lava level drops, which is we're just seeing just now in the last few hours enough, you don't really see that lava falls as much. So we'll look at the 24-hour animation here shortly as well. But otherwise, you've been able to see lava all week, as I was just saying, both in the persistent area and randomly elsewhere, wherever the ooze-up's happening at that moment in time. So here's S1 for the last 20, or let's reload it right now. And that last view right there had a little lava fall, but maybe a little bit better light. See, it feels like it's needing to load. Well, here's our 24-hour animation. Let's zoom it into the pit. And obviously not a whole lot of resolution here when it's dark and blown out. But now, there in the daytime, you see a little bit more of that lava fall forming, lower lava level down there at the bottom. So that's as good as we're going to get it right now. And we will move on. Viewing still good from all those areas over there. So what we will do now is transition from the viewing report, which viewing is still great, and show you guys a little more of maybe what you can see in the variations by looking at the media of the week, released from the USGS. So I'll start off with the video that we previewed a little bit earlier. Just zoomed in part of the West Vent Pond, but you can see here May 26th is the date. There is that larger lava lake area, a pit. And here is the southeast pond. We're going to zoom in on it. And there is that zoomed in portion of the video. So as we've described this already, I'll just let you enjoy it here. And bubbling, and remember it's shooting out, and you can just saw that view of where it's shooting out to, that main active surface. And this is about a week ago. So lava level was consistent and high, and there's no drop as is happening now visible in that clip, but still pretty cool to see. Mahalo USGS. The next video here is May 31st, and they are taking 2 months from the B1 web camera and taking 1 image per day in the daytime. And I loop it a few times here, so let's play that for you guys. This is a B1 camera. Let's try to get it fit on a screen the whole way here. And there you hopefully can see that crater floor really lifting up. This is our, I would call it also the time lapse of the week, but we haven't been awarded those in a while because for the most part it's been the same. Still really cool to see that crust filling, right? You barely see flow, you just kind of see a new chunk of rock covering an area here or there. That's a temporary flow there. Let's rewind that back again. And really, yeah, you can see here this endogenic growth as they're describing it. Cool to see the coming and going of those cones as well. And you can see how the cone pops up and is lifted up with a crust too. I thought that was pretty interesting. Right in there. Yeah, so hopefully that helps answer and illustrate Jason's question and point there too. All right, so we will turn to monitoring data next and see what we can see there. So let's transition there. And here's our review of our current web cameras. You can see in the F1 there, it is looking still dropped down from before. And we just saw some of the others, our V1 image. We'll look at the V1 camera shortly here too. Also looking dropped down. You can see that crater wall clearly exposed there. Still active lava in there, however. All right, so since we just saw that B1 camera and saw the lava crust being lifted up, we can review here the whole eruption lava depth from September 2021 until now. And you can see here we're still on a steady rise. There it is. You can ignore this variation. That was when a lava laser was pointed at a different part of the lake. And it's actually catching more of the variation. We'll see something similar to that just happened last week. And so we're seeing the signal on that lava laser as well. We may see this pattern possibly start resuming over here in this next little bit. But the important thing really is this average coming up, and it stayed steady there, right? That's, for the most part, telling us the rate's been pretty steady for a while also. As far as the GPS, the distance across the summit caldera is shown up here in this top panel, and you can see that after eruption it had contracted quite a bit. It had a little bit of adjustment back and forth, and it's really been on a rise and kind of accelerating rise for a little while, except for this more recent trend, which we've been waiting to see what would happen and if it would change and what exactly is going on there. But it's dragging on for a little while now, and we've had similar little episodes, right, where it's dropped down and come back up. So, but it's getting to be long lasting enough to keep an eye on this thing, and perhaps if the eruption rate is sustaining at the higher end of what's possible, then you're relieving enough pressure to start the crater walls not spreading as fast or as far, or even coming closer together at some point in time. Right? That's one possibility. Of course, this thing is on the edge of the south flank, so when you have south flank movement, it can affect this a little bit as well, but probably not enough that it's changing the trend here. Probably just the size of the trend. So we'll move on from that. We can look at the East Rift Zone. We can see in the Rift Zone it doesn't show anything extra in that same period of time. So everything's still contracting, coming closer together. There could always be trickles of lava in there, but that's normal, and there's nothing to be alarmed about. It's actually, for the most part, exhaling and still kind of coming back together. It's losing pressure internally. So, all right, we'll zoom in on a 1 week summit lava depth, and there it is at the top. So looking at this far right end where we are right now, you can see that we've dropped down quite a bit. We were at 359 and we're down to 353, so 6 meters. That's probably about 20 feet-ish of drop, just in the last 12 hours maybe or so. And you can see that we had another variation a couple days before that, not quite as big, and dropped down and up there as well. And to illustrate that, we'll come to the V1 camera here. And so let's get this thing going. There's a V1 camera. You see early on in a week, you can see the changing nature of the spatter ramparts, and here, there, and here. But really at the end, you see that dropping down at a lava level, where it starts exposing that crater wall right in there, all the way around, coming right through there. Yeah, and you also see this gap open up and look more like a rapids, and we're looking at that lava falls from the upper side from this perspective here. So pretty cool. There is the V1 camera. You can see that little variation just in the last day, and then a couple days before that, slight little up and down right there. comes up, and that starts going on more quickly right there at the end. So that's what we're noting, and that's different from before, from last week, right? We actually noted last week this little change in signal right here, where it seemed like it was dropping down, and it wasn't quite clear at the time whether that was possibly one of these overflows that occurs off the side of the crater, or if the laser had been moved. We brought up both possibilities. And actually, I see Ken is back with us here in the chat. Thanks for your comments, Ken, and we'll show everyone else here. So Ken is commenting that the drop reflects the instrument being repositioned by HVO staff. And here he is. Over the past several months, the crater floor of Haleʻimaʻamaʻu has been slowly rising endogenously, and this resulted in the laser rangefinder not being aimed at an ideal location on the surface of the active lava pond surface. That aim was repositioned yesterday, and that is a drop on the lake level chart. So, mahalo for your insight, Ken, there. Seems like you were in a know a little before us, so please, thanks for sharing. And you can see Ken also follows up with looking at the lake chart in the last week. I'm wondering if we're seeing a dramatic increase in the flow rate now, right? So let's go back and look at our chart again, and you can see a little bit of maybe what he was talking about here. If I zoom it in. And so there is our repositioning right here. And right after that happens, you start seeing this coming up pretty quick. And so pretty interesting rise there, right? And it was not quite clear if that was an increase in rate. It might have been. I don't think I have enough information to judge at this point, right? I'd like to hear from USGS directly if there's something else going on there. But what we do see coming after that occurs, this sensitivity to the lake level that occurs here and that we're seeing here again, right? That leads to the possibility that there was that extra sensitivity as well, we'll call it, back in this part of the graph too. So it might have been one of these small variations rather than a rapid increase in the rate. It's hard to tell exactly from there, but just to point out within this 1 week what patterns we're seeing there, right? And corresponding to the summit tilt's been flat the entire time, and that's why we suspected this was something abnormal, because there was no corresponding tilt signal. It was one of the hints. But you can see that tilt is also pretty flat here, and we're having a drop in lava level a little bit as well, right? Obviously here at the right end, when a tilt's dropping on the order of 2.5 microradians, then we're having that larger drop in lava level too. We'll zoom it out. Here is the last month. So here is that adjustment. Here is that a couple of days ago drop, and here's our larger drop on the right end right there. You can see there have been some step-ups and some other little noise perhaps, so there may have been other adjustments occurring. We'll be curious to know here, but ultimately the pattern is preserved, and I always like seeing, I'm sure that in general scientists prefer to have better resolution and get more data than less, so cool to see that being repositioned and get more information here, right? Looking at the last month summit tilt, you can see here we've had these deflation-inflation events with no corresponding signal on the depth chart, but here at the right end we're perhaps seeing that once again, right? The big one and even a small one a little bit here, slight little deflation-inflation event, very small kind. So that's the monitoring signals and taking us all the way through SO2, and SO2 has varied with a tilt for a large majority of the eruption, and we still see it bouncing around between close to 4,000 tons per day a week ago and this past week, and in between and prior to that down here in a 2,000 to 2,500 tons per day range. So these are significant values. It's quite a lot of VOG coming out compared to some regular factory United States. It's a significant volume kind of thing, right? It's worse than living next to a factory, basically. So there are certainly effects, and we'll turn to our hazards and our because gas is our primary hazard as stated by the USGS here, and it's directly related to how much is coming out, which is what's shown here, as well as what's where the wind is blowing, which direction it's going to take it. So let's move.
Got a comment from Christina out in Captain Cook area. Says VOG is back heavily in South Kona.
Yeah, mahalo, Christine. Yeah, that's the point that I'm getting to right now. So good segue, mahalo, Dane. Here's our VOG mapping forecast from the VOG mapping project, Manila. Whoops, looks like I zoomed in a little too much there. A little laggy. So there it is, and what you can see is the source right here, and VOG is blowing off in this direction, but there's this whirl going on right in here, right? I'm not sure which way it's whirling exactly, but you can see all this VOG is caught up in this whole Kona area on the west part of the island, right? And take all the Waikoloa, Pohakoloa, not quite to Hawaii, but you know, getting into Kohala, right? Up here. And the whole southwest has all been swamped as well too. So that's the forecast. It doesn't actually look like it's going to clear up, unfortunately, Christina. Keep taking your precautions. I wanted to come here to the First of the National Park website and look at the hazards there. You can see there is the plume blowing southwest, everything upwind in the green, right? But if you look at this zoomed in map, let's see if it'll let me zoom it in here. This little corner, right? On a larger scale, here's Halima'uma'u. We saw everything upwind is green, but there are some stations over here, like Kahuku, that are currently showing green, but are often much more directly in the path of the VOG. So if we go to scroll down here and click on this advisory history by site, right there, we'll click on that. Then that gives us two columns, SO2 on the left and particulate matter 2.5 on the right. And you can see greens for the most part, except this one station at Kahuku facilities having got pretty bad in the last couple of days here. Yellow, orange, red, orange, yellow, before coming back to green. Yeah. Make that a little bigger so it can be seen by everyone there. So fortunately that's a little out of the way, but it is kind of an indicator of what ocean view's like, and that is part of that zone Christina is just talking about there as well. But let's not just rely on our park sensors. Let's go to purple air. And here it is, and you can actually see we got a signal of 82 over here in Kīlauea, Kona. 10-minute average today, right now. And if I pull up the graph here, let's see if it'll get me zoom this into. Right, it's interesting. Well, this rainbow is all the way down here at this bottom part of the graph, right? Because that's where we are. We're actually in that orange-red, but it's all the way down here because there's been several spikes. One there, one there, one there, you know, that have been large. And then there's this really big one back here on May 30th, afternoon on May 30th. And I think, you know, I looked at that and think, oh, maybe that's an anomaly. Maybe some big truck drove by that station right there. So we could look around. We can look down here in South Kona, right? That's the 75. You don't see quite that spike in that one day right there, but you do see it's been going in and out of the yellow quite a bit. Right, let's look down here at, where is it showing that line? Yeah, this is still Kaohe. Okay, so let's go down here to Nalehu or Pahala. And there, looks like, earlier I was seeing these spikes in some of these other graphs, but it seems like it's getting cleaned up a little bit, maybe perhaps here. So yeah, you can see here, getting into the yellow quite a bit still. In the Lionsgate Farm, Kahuku, I think is it adding them all together? Maybe that's what it's doing here. I'm not quite sure. It's okay, here's Pahala, and then we see more of these other spikes that can happen into the purple and red too. So in any case, I won't go through everywhere, but you can see, maybe if I can get that layer off of there, but oh, there we go. You can see that there is VOG effects all the way up and down that Kona coast. So still happening. All right, and once again, this is all mahalo to the USGS Hawaiian Volcano Observatory. All this information is just reviewing and recapping their daily updates to the best of our ability. You can see here the most recent update today. Not a whole lot of change, no changes in the rift zone. In the summit, they've shown 5 meters drop 16 feet at the time of the update being written this morning. Same measurements of stuff from before. As far as output, right? Total rise of 348 feet, 106 meters, and 20 billion gallons of lava, 77 million cubic meters, same values as the last couple weeks. SO2 rates, 3,900. East Rift Zone, no tremor, nothing unusual there. And then here, hazard analysis is the same as usual, right? High levels of volcanic gas, a primary hazard of concern. And it can have far-reaching effects downwind. So there's some publications here and a daily update, and you can find more information on the VOG and, good resources here for dealing with the VOG, right? So check that out. It's in pretty much every USGS daily update. You can find these links at the bottom. All right, so that is the hazard summary, and that brings us to our halfway point, Dane.
All right. Well, we got some thank yous to do here. We had a couple super chats come through. First one was from Langer, 1234, and they both asked questions, so we'll just hold off on the questions for a minute, and then we'll get in those. Has there ever been he got a $20 super chat, has there ever been a successful attempt at redirecting lava flows? I think they tried in Iceland. And then we had a $5 super chat from Sean. He also asked a question about what is VOG made up of, and how much can huff before things bad happen. All right, we'll get to those shortly, but we've got to thank everybody else. First, if you tuned in today, I appreciate you. Viewers like you really keep the channel going. We rely on viewers like you. We don't have a monetary budget to throw into advertising, so those clicks, those likes, subscribes, shares really help, comments help, all that stuff, and we really appreciate it. We also want to thank our sponsors, mainly Kilauea's Bar and Grill in Pahoa and their new location out in Orchid Land. If you haven't been there, it's definitely worth checking out. Always busy, but not too busy unless one of the bands are playing, type of things. They do have live music there. They have some traditional dishes, competitive prices with a little bit of unique spins on those dishes. So yeah, we want to thank Kilauea's Bar and Grill for being our longtime supporters at this point. And with that, I think we can go in and get a few questions done. What do you think?
Yeah, sounds good.
All right, let's start off with Langer's one about the successful attempt at diverting a lava flow or redirecting a lava flow. What are your thoughts on that? Anything come to mind?
Yeah, so, there's some examples here in Hawaii too, right? We can most recently talk about 2014 and 15 in Pahoa, where the flow was petering out and redirecting uphill, but as that bulk came downhill towards a family's house in Pahoa, they built a big berm behind their house, and that saved their house from the flow. Now it helped that the eruption rate went down also, but without the berm, it probably would have been taken. So that's kind of a small kind of example, right? There are. Go ahead.
I just did a Google search on it just to pull a few. The Iceland one was 1973, and
to save the harbor.
I'll try and pronounce the name, but it's going to be terrible, and I apologize to anybody of Icelandic descent. Vestmenagir, and they use water cannons on that one. And then Etna, eruption in 1983. Apparently they had like 3 berms. It overran the first berm, but the second one kind of caught it. Mm-hmm. Few other smaller cases. Lots of cases of them trying and not working. We have a lot of those in Hawaii. Really the best success story is that one house type of thing. But yeah, just wanted to chime in with those.
Yeah, those are the famous ones, right? For sure. Right. The Monolo Observatory's got a giant V-shaped diversion barrier uphill from it because it's up at 11,000 feet on flank of a giant volcano. So, it's a strategy that's used. The thing though, we got to be really careful of is what we've discussed in the past as far as official response is it's hard for a government to actually build a diversion barrier that's going to save one person's house but destroy another person's house as a consequence.
Right, because as soon as the government diverts it, they now own that lava flow. Basically. Right.
So now they have some responsibility for where it went if they diverted it. So in most cases, you're going to let it be, let the disaster run its course, so to speak, and then come and try to clean up rather than try to direct it. Now, it might be different if there's a clear spot where you can put it and there's no one in the way. You might have a different calculation there. So it's really
Right.
case by case kind of thing. It might vary country by country, the willingness of the authorities to do that kind of thing. Iceland's a famous example, right, with the water cannons, right? You got to be careful. You got to use fresh water. If you use salt water, you start generating those hydrochloric acid plumes like ocean entries had. That whole laze, which is different from the VOG that we can get into too. But yeah, that's what comes to mind. It's possible for sure. It's been done successfully in the past with various methods, but it's questionable for the future because of those implications, right? As far as like liability or responsibility or trying to affect an act of nature kind of thing.
Right. Let's go to Sean's question, who is asking about the VOG. What is VOG made up of, and how much can you huff before bad things happen? I might be able to talk on the second part of that one a little bit if you want to take the first.
Yeah, I'm trying to find my graphic I hit, but I haven't had enough time to find it here yet. There's all kinds of things that are in the VOG, but what comes out of the volcano is essentially water vapor and carbon dioxide and sulfur dioxide and a bunch of other stuff in smaller amounts, right, to kind of generalize it. That other stuff matters because a lot of times it can form particulates, and you have like heavy metals and those kind of things that can be flying around too. So you got to make sure to be careful with that, right? But mostly what we talk about when we talk about VOG is the SO2 when you're near the volcano, and as it flies through the air, it reacts with that water in the air and it forms sulfuric acid, and it forms sulfate particles as well eventually. So like the farther it travels aloft in the air, the more it changes from that pure gas to the sulfate particles, and those are the ones that actually physically block the light, right? That make it look foggy and change the sunsets and all of that. So that's the very general of it. I'll keep looking at my graphic if you want to try to take the second part, Daniel.
Yeah, definitely. So the second part of that one is they measure it with the SO2 meters, right? And it's on a scale where basically a 1 is you get a strong warning to get out of there, and everybody's reaction to the VOG is going to be different depending on like your sensitivity to it. Some people can have like an allergic reaction to it. It's pretty strong. But you can get up to 2, and that's going to be pretty bad. The back of your throat's going to be burning, stuff like that. But you can still handle them. It's when it gets higher, and that really the problem is the prolonged exposure, right? If you're there for an hour, that's one thing. If you're going to stay the night at a house that's getting constant exposure, for days on end, okay, that's entirely different. So yeah, it all depends on the personal exposure and your ability to get the right 3M mask with the right filters to be able to withstand it. The higher levels, low levels like 1 and 2s, it's gonna be rough without a mask. You can weather that with a mask, but without, you can do it, but you better not be out there long. Any luck with the graphic?
So here's what we're gonna do. We're gonna transition to that website that was just linked with the USGS. And so let me get it on the screen here properly. And okay, so a couple ways, right? So from here, we can click on USGS, or we can check on a VOG. So let's look at the USGS link. Volcanic air pollutions in Hawaii. Well, let's try. We're gonna click in the right spot. There we go. And see here. What if it has a little graphic for us? Our PDF isn't quite rendering great. So the directions, the measurements, how much is there? Advisory qualities. Okay, this didn't really have a graphic like I was looking for. I'm sure it says it in here. But let's look at this other one, perhaps. What is VOG? Let's click on that. All right. No, it's not really giving, I don't know, somewhere I can't really find a graphic. Sorry, guys.
Sorry. It's all right. All right, let's move to the next one then.
I was trying to find all those trace element stuff for you guys, right? Like, show you guys what all that stuff is here.
There's a whole bunch of stuff in there, and not a lot of it's good.
Yeah, I can't find the what I'm looking for.
It's all right.
Yeah.
It's all right. All right, so next question. Judy asks, what does it mean when they say magma or lava is buoyant?
So it's about the density of it relative to the density of what else is around it, essentially, right? So it being, we're talking about that whole crust essentially being buoyant above the lava lake now, allowing it to be floaty, right? Maybe that's another way to think of it, as throw out a quasi word there. It's floaty, right? It's able to stay floating above something that's denser than it, right? So even the lava is coming in below that crust, it's not just coming up and over and swallowing and overwhelming it. It's actually somehow denser, even with a gas in it. It's denser, it's heavier than that island. So rather than go over it, it just stays under it and it pushes it up. If that makes sense, maybe that's how I can. That's what I'll try, unless we have something else to add, Dane.
I think that works. Looking around to see if there's any more questions. The last one we'll go with is VOG low lying like fog, or does it get higher? Question from Richard.
It really depends on the winds. I've seen it low lying when there's very little wind, slack winds, like more like in the volcano area, and it'll fill the caldera area depression, and then it'll kind of move downhill from there, right, getting the upper parts of the volcano first. When a wind is blowing it, it's usually higher up, but it's not necessarily above ground, because higher up might be 1,000-2,000 feet elevation, where when it comes back around a corner of the island, around ocean view, that's where people are living at that elevation, and it goes right across the ground there too. So it varies.
Right. There is one more question here from Facebook, and this one I don't really think we can go into much, but we'll talk about it a little bit. Chaos, in 2018, they were saying that the sulfur might be helping the rapid ohia death. Is there an update, and did it help or not?
I don't have an update. Rapid ohia death is still around. We do know that.
Yeah.
So it might have helped, but it definitely didn't knock it out, anything like that. Right. So it's good question. I mean, we'll have to try to ask some resources about that.
I will say that it didn't hurt, type of thing. Like, it didn't accelerate the rapid ohia death. The volcano wiped out a good amount of ohias itself, but like I want to say in my yard, I was getting it, like it was coming before the eruption. Like several trees died, and few have died since. But if I had to guess, it would be the trend line was screwed up by the eruption. But that's all just subjective opinion. All right. Well, I think that does it for questions. We will be doing one more segment at the end. If you got a question, go ahead and throw it in chat, and we'll see what we can do with it. I'm going to go over some 2018 stuff, the fall Kapoho, and the lava delta.
Yeah, starting off with our earthquakes for the past week, and we'll touch on Monolo a little bit also. There's not a whole lot of excitement there, to be honest. But we will cover it for completeness, as usual. So there's our recent earthquakes map. Let me get my... All right, here we go. So there's our recent earthquakes. The largest one in the last week, 2.7. South of the Pahala, it's down in here. There was a 2.6 that was just offshore earlier today. There's a 2.6 in Pahala, deep as well. Not very big. For the most part, we have one farther offshore, 2.5. There's one over in the Kona side, 2.5. There's one over in Honomu, 2.2. All within the range, nothing unusual. Some by Mauna Loa's eastern flank here, 2.3, 1.8. Right, so it seems like the flank might have some movement going on there, but that's all normal and within the background rates here for both volcanoes. But to show it to you graphically, let's come down here to our 1-year earthquakes on Kilauea. So here we are, pretty low on our right side here. You can see that basal earthquake swarm under the caldera, and didn't directly change much on the surface, although we have seen perhaps a sustained high rate of eruption. So maybe that's just part of the process. And earlier on, we saw the intrusion and build up to the eruption way back August and September of 2021. So in comparison, really not much going on. Pretty low normal variation going on there. Looking over the last month here, a little closer. Nothing really to speak of to see there. Pretty normal up and down. Here is a map of the last week. You can see still some clusters under the summit. South flank still. Few of these deep ones over here in that deep conduit feeder area. And Pahala still happening as usual. And there it is in cross section. There's those deep ones extending that period that we've had them there for a few months now. And in time, you can see maybe a little bit slower in Pahala and then a little more in Pahala. A couple little clusters coming through, so it's a little slower than typical, but it's within the range for sure. Last month, similar pattern. There's the map view. There's a cross section view, and you can see more of a steady pattern on a month scale. Both Pahala and this whole south flank region up here too. So nothing really to speak of right there. So make sure to cover it as usual. Earthquake rates in Mauna Loa are actually down quite a bit if we look at the summit region especially, right? So down to, I think it was 30 earthquakes reported this last week. And yeah, lower than pretty much everything since March, within that low average range. And as we saw before, even if it does go up, it doesn't necessarily mean any change in eruption. It just means it's moving around a little more. And curious when it happens under the summit, building up more pressure under the summit, and under the flank, more so the flank moving. We can go into Mauna Loa again at some point in time, but there's really not a whole lot happening to really make it urgent. So we'll move on. Cross caldera distance at Mauna Loa, north to south as well in that summit region. You can see it in the past. It has extended more of a neutral signal, we'll call it here, and maybe rising a little more recently, but nothing major. All within a normal over the last year. So that is Mauna Loa update. I, for some reason, I always forget to put this Mauna Loa label. So I'll throw it up there for just a second. There's our Mauna Loa label. Before we transition to this week's USGS Volcano Watch. All right, so today it's Kilauea's colleagues. What other volcanoes are currently erupting on Earth? You can go to hawaiitracker.com to find this. It's posted up there already. And you can see here that they're relying on the Smithsonian Institution's Global Volcanism Program, the GVP list of erupting volcanoes. So typically in a given year, 40 to 50 volcanoes erupt, or less than 10% of the world's active volcanoes. So they do a little comparison. Here's a typical map that you get from that GVP website. We'll check it out here shortly as well. And we'll just pull out a couple highlights here as well, right? Kilauea has been on and off the list more often than in the past. It had a continuous eruption for many years from Pu'o'o, and this basically was off for a while and back on, went off, and now it's back on again. Typically in a given year, 40 to 50 volcanoes erupt, as we just said. As of March 17th, 48 volcanoes in erupting status. All right, that could be ones that are intermittently, without a break of 3 months or more. So there are some that have been long-lasting. Yasur in Vanuatu since 1774, intermittently. That's close to 250 years. Stromboli volcano in Italy is thought to have been erupting semi-continuously for 10 times as long, according to Roman records. So you're looking at over 2,000 years there, right? The lighthouse of the Mediterranean, as reliable as it's been erupting before there were fancier lighthouses. Most recent volcano to join the list is Volcano Wolf in Galapagos, in Ecuador, South America, offshore South America, right? Began erupting January 6th of this year with a 5-mile-long fissure sending flows about 11 miles down the flanks. The organization monitoring reported the eruption ended on May 5th, so that one's going to be off the list pretty soon too, unless it begins in the next 2 months once again. Breakdown: 1 in Antarctica, 2 in Europe, 4 in Africa, 4 in North America, 6 in Asia, including 3 in Kamchatka in the Russian Far East, 7 in Central America, 7 in South America, and 17 in Oceania. Right, no surprise within the quote-unquote Ring of Fire and all those tectonic plate boundaries. So keep moving from there. Well-known volcanoes on the list include Erebus, Antarctica, Erta Ale, Ethiopia, Africa, Those are 3 of the 8 on Earth known to host persistent lava lakes. Lesser known volcanoes on that list include Kona in Indonesia, Telica in Nicaragua, and Suwanosejima in Japan. My apologies for the pronunciation, all of those. Dukono since 1933 sporadically. Telica since April 2021, whereas 2004 for Suwanosejima. Hopefully I didn't butcher it all for a second time there. All right. Domestically, 4 volcanoes in the U.S. making up the program, including Kilauea and 3 in Alaska. The 3 in Alaska, Pavlov on the Alaskan Peninsula since August 2021, Great Sitkin and the Central Aleutians since May 2021, and Semisupochnoe in the Western Aleutians since February 2021. So far, human-centric. This is all the volcanoes that we can see above sea level, but the whole mid-ocean ridges account for 75% of the production and eruptions, you'd imagine, as well. There are a few places on land that actually expose those mid-ocean ridges, and Iceland is a good example of that. So a recent eruption of Fagradalsfjall, forgive me for a third time, from March to September 2021, a spectacular example of mid-ocean ridge volcanism, and one of the rare times when mid-ocean ridge volcanoes made the GVP list. So you can go to volcano.si.edu. Let's make that big so you can see it in case you can't hear me. Volcano.si.edu. And you get to their site here. That looks like this. New activity and highlights here. You can see all those volcanoes. You can click current eruptions. On 17th of March, 48. You can see in 2022, there were 5 new ones and 54 total so far. In 2021, there were 31 new ones and 79 total. The average from 2011 to 2020, 34 new ones and 79 total. I'll give you some idea there, right? So you can go and you can click on these and it'll give you more data and all that. Good FAQ, which countries have got the most volcanoes? US, Indonesia, Japan, Russia, Chile. How many are currently erupting? 40 to 50. How many Holocene in the last 12,000 years? 1,350 have been active. Has volcanic activity been increasing? We hear that one a lot. No. What was erupting in any given year? The range has been 56 to 88 total eruptions per year since 1991. Which ones have had the longest eruptions? 101 eruptions have been 5 years or longer. Which ones have the most people living nearby? There are 10 with more than 1 million people within 5 kilometers. Right, those are the scariest ones there. Which volcanoes are the most noteworthy? There are 187 with significant activity or impacts. Right, so of all those, these are really what you care about is all those. So you can click on any of those things and get more info. See bulletins from all over the world, Etna, La Palma, Fuego, Kilauea. Right, you see Kilauea is back, showing that new eruption in the last quarter of last year, right? A kind of a quarterly update kind of thing. So that is the GVP, and we've mentioned it before. Nice to have it published and documented by the USGS, and nice to see that they're updating their website as well to make these frequently asked questions the main thing here, right? As we've been saying for a while too.
We do have a comment that fits in well here.
Yeah.
One of the users on YouTube says, and we're going to go for the record for the most wrongly pronounced volcano names this episode. So I'm going to throw in another one. He says Mount Ruapehu. Ruapehu is breathing a little deeper, seismic unrest, a little bit of tremor, it looks like. Last eruption was in the 96-ish. Yeah, just lots of activity out there. Now we get to see it all, right? Like, throw it back 50 years, maybe you never hear about an activity at in New Zealand, being in Hawaii.
Yeah, for sure. So yeah, I think I could find Ruapehu on here, but maybe there it is. Ruapehu, high fatality eruption, frequently active. It looks like I got the wrong title on here prematurely. But yeah, there is Ruapehu in New Zealand. 24 May, elevated unrest continued, though at reduced levels. Tremor is above normal. Lake water temperature still above normal. but cooling slightly recently. So interesting thing to check out there. So these guys compile everything, so but maybe not quite up to the hour information, but pretty cool and awesome encyclopedia of volcanoes, essentially, is what you see here. All right, so now we're going to move on to 2018. I was going to start it off, Dane, by just showing a 30-second recap here of video footage of that week, that 5th week of the eruption of 2018. Ahu'aila'au became the dominant event. You can see produce that giant river of lava that flowed through Leilani, around the north side of PGV, down the highway, all around Kapoho and filled Kapoho Bay. So here it is. Yeah. I should probably have said it sooner. Disclaimer, right? If you guys are going to likely be triggered by this, we're going to be doing 2018, and thanks for joining us, but it does get a little intense here. Yeah, go ahead, Dane.
Yeah, about this time when Fisher came up, like, the eruption was still working its way back up the rift, so the fissures were resetting every day, every other day type of thing, maybe every third day, just continuing to transition. So there was still a real question about, does this thing continue to progress up the rift zone? Because we saw Fissure 24 open above Fissure 8, and is it going to continue working up that way, or does it reset? And I remember the leading, like, the leading thing I was hearing at that point was, oh, it's going to reset. Oh, watch, it's going to reset. You know, out in the word around town. And it ended up just staying there. And that was really mind-blowing just to see it perch up like that and just not quit at that point.
Yeah, there was a hint.
It was hard to see it. Yeah, there was a hint, but
yeah, I mean,
it was hard to see at the time.
Yeah, I only say that because, I mean, you know, it's easier, of course, in hindsight, right? But like when that first week of fissures opened up, when Fissure 8 opened the first time, it put out a mile-long flow that first time as well. So it was from the very beginning one of the easier places for the lava to come out early on, even when it was that stickier lava. So when it came later to find a spot, in hindsight, it's not surprising that it was that spot. But still shocking that it stayed and parked there, and it, you know, really, that was the whole, pretty much the rest of this eruption was all about Ahu'aila'au, aka Fissure 8. Right?
Right.
So there it is. Maybe I don't have to show that piece of it again. We did want to talk about how the eruption was leading up to that point in time, and how the response was as well, right? So I pulled this image from the main USGS paper by Tina Neal and others, 2019. And what this is showing is the example lava flow forecast map. And what it's showing is a forecast map from May 27th of 2018, right? And it's, if I can zoom it in here, right, there's a lot of stuff on here. The gray outline is how far the flows were at the time this prediction was made. There is a black line here showing the eventual extent of the flows, where they actually went ultimately there. Right. There is these blue lines that are these lines of steepest descent that shows more or less a drainage pattern of the volcano. And you can see that, like, this line here would tend to lead you off to the north over this way, right over there, right? East of Nana Valley and towards the ocean, south of Hawaiian Beaches area there, right? So more communities to be at risk if that were to have happened. And ultimately what happened was this little zone right in here. This is something we covered with Les Peterson quite a bit during the time. There is that, with this resolution map, there's like a separate little drainage going off this way and a little division right in here. And what ended up happening was that the flow actually took this route, right, and it utilized the highway apparently to bridge that little division, and essentially not exactly jumped, but it went to an area that was not as predicted, right? So if I zoom this out, these areas that are orangish are showing the more likely or less likely path of the flow, and so it was pretty clear that it was going to go off in this direction, But then when it got to here, it became ambiguous, where it could have gone off, and you can see some orange colors off here where it could have gone off that way. But they were also seeing that it could have jumped over and it could have gone off this way. And it was kind of a little bit of both, right? So, but you can see the model clearly shows a risk to Kapoho here on May 27th when this model is made. So I remember May 27th was a day we were in a public meeting day, right? We're going to the community meeting.
Yeah.
And we're waiting for more word because it was pretty obvious that this was an issue that was coming up. And it was shocking to not have heard anything happen there. And then that's what was the beginning of the evacuations and everyone leave. Okay, it was false alarm. Okay, now you really got to leave, and all of that.
Right. One of the things that we were getting tipped off about, I mean, this blue line, the steepest descent lines, they're very good to quickly show somebody where the lava is most likely going to go. The thing is a lot of information gets lost in the development of these in terms of versus like a topographical map, right, where the lines are spaced apart, and that shows you where the flatlands. It's really difficult to see the flatland. What Les ended up doing in 2018 was taking the raw data that USGS processed in order to create the blue lines, processing it himself, and creating his own blue lines with the slightly different parameters. The thing is where those lines disagreed with each other, that's where we figured out, like, okay, this is a flatland. It doesn't know what to do here. It's not obvious, so it's filling in the gaps. And that's right. Kind of what happened right by that road there is they filled in the gaps, and the tolerance was so close that just a road and trees, the biomass, and then there being a road is enough to tip the scale and completely send the flow in a different way. I mean, that's at least my interpretation of that whole thing.
Yeah. I think that's what I really think we can remember to try to improve on was how that response really went, right? That's really I think the greatest honor we can do Kapoho residents at this point in time, because it was so devastating. That was the most devastating week of the eruption. It was kind of shocking to a lot of people, right? As far as like how much time or how little time, or when they thought they had time or didn't have time, and all of that was a little jumbled, and I can't tell a story as well as a resident themselves could. Right. But it all relates to this image right here, so that's one thing that has to be mentioned off the top, out of respect, really. It should have been a better treatment of the residents as far as more time to get everything out, and not as shocking, and more coherence top to bottom, even on May 27th at the public meeting, having something mentioned.
Right. And the 27th meeting was really disappointing. We expected that to be the time when the sirens go out and everybody gets warned right then and there. Instead, They barely said anything. And then later that night, about midnight, they went through the neighborhoods waking everybody up to tell them. It's like, guys, we just had everybody assembled hours ago.
Yeah. So they went through it May 27th in the middle of the night. Then it didn't actually come through until June 1st, right? And then people went back. Then when it actually did come through, it was it was a mess.
And there was things that were frustrating. There were like guys that were trying to go back in, being told they can't. And then I have other friends that the cops told them, or the National Guard told them they can't go, and they just drove around them and continued to make runs the entire day until the lava took four corners, while other people weren't allowed to. It just wild. It was wild down there.
Yeah, so it was one of the saddest weeks, just because it feels like we could have done a little bit better. It still would have been a major loss no matter what, but it just seems like you could ease some of the suffering in a way and, smooth some of those edges a little bit. Those little small dignities are, sometimes make all the difference in that kind of trauma situation.
One of the things about it is that distal tip, that lava flow when it was coming down the hill, it had such a variable rate of speed, right? So it would, every time it found a hill, it would go really fast, and then it'd get into a flat spot, and it would die off. But every time it found a hill, people would freak out, like, oh my God, it's moving at 900 feet an hour. If it continues this up, it'll be in Kapoho by morning. And then it hits a flat spot and doesn't move for 12 hours. Type of thing.
So it had been doing that for days, right? And that's why we saw that the 25th, the 26th. We're like, okay, well, someone's got to say something. And the 27th, maybe they're just waiting for the meeting to say something. Maybe they're waiting, and then the chance came and went, we're like, okay, well, I guess they weren't waiting, just weren't going to do it. They could have issued a warning days before that, right? As we were worried about it, right? You're not trying to scare anybody at the time, but you know, very real possibility to be aware of that was something that could happen. So I like to show a video of Mileka Lincoln when she was talking with Ikaika Marzo on Facebook Live, just describing what she saw when she rode with Ikaika by boat to Pohoiki, and I got off and I looked around the area, and she described both the flows that went south from that fissure complex towards the Malama Key area, Mackenzie Park area, but also the ones that went to Kapoho, and it's not quite clear, but from the clip. But I'll play it for you guys.
Really see it from 6 to 8 miles away, and it was just raging.
I mean, an unbelievable experience. The whole thing feels very surreal. It's I've had several people now say that it feels like being in a science fiction movie, and I would say that really felt like the case yesterday, especially when we finally docked at Pohoiki, and to see Isaac Hale Beach Park just empty, just abandoned. There was not a single person except for Merlin. That felt like being in a scene of Walking Dead, when we finally walked all the way down Highway 137 to where the very first lava entry had crossed, right there at Malama Flats, and to stand on top of what was at least 45, 50 feet of lava, and from there to be able to look back at the fountaining Fissure 8, that was just so eerie. That's the only really way to describe it. It's like a ghost town. There were people who clearly had like left their lights on in their homes, car doors open. You could tell that people picked up and left with no indication of when they might be coming back. They thought they were. I mean, I think that's what lights on and car doors open mean, right? People thought, okay, we'll be right back. We're leaving now in a frantic panic, but we're going to get a chance to come home. And all of those people are realizing that might not be the case.
Yeah, that's always stuck with me, that sequence, right? Talking about those car doors open and lights on, yeah.
Yeah, and it was like that after the eruption too. Going to the areas that still evacuated. And you would see crazy stuff in there. I saw feral pigs making burrows out of the new lava flows. Wild sheep that we thought was a horse. It was so overgrown and bushy type of thing. Just running around. And a dog that we named Lucky and brought it food. Like, it's wild stuff. Like, in the kapukas. Just wild in there. Totally post-apocalyptic vibes.
Yeah, and of course there's the whole story of Merlin, the dog that was rescued and then readopted by Leslie at Kaleo's, our sponsor. So I did a whole long, maybe we can find a link, Dane, and repost it. We did a whole community response to the 2000 eruption stream a while ago. It's a little on the long side, but if you guys want to dive into like really what the community did, it's
right.
Pretty comprehensive, and all the things people did. It talks about Merlin, all the different things people did, which is a lot, right? That's why the video is kind of long, because people did a lot. The community really rose up to respond. We'll focus on that in more detail in some of the coming weeks, but that's worth mentioning as well as one of the big positives of what happened. However, we did have this view. Cut off that helicopter noise. Apologies there. Sometimes these things reset. And they're in lava entering that shallow Kapoho Bay video and photograph there. One first video from USGS, and we show one more just to remember Kapoho Bay. And I should have found one that was Kapoho Bay before, and not just a distraction, but
it's in the Drones On series if anybody wants to check it out.
So yeah, there is lava going ocean, and see, there's still houses in the shoreline nearby. Not a whole lot of explosions happening everywhere. If I pull this one back, actually, I can pull it back to here. There is a spot right in here, if you look in there, you start some brown cloud come out, and that's the little explosions happening. But not as many as you saw in a pool era at times. And that's something we'll talk about as we shift our discussion from all the devastation to some of the science that was learned from this tragedy here. So just want to get you a view of what that looked like when lava was going into the ocean there. There it is, first video, second video coming up, and filling that shallow bay there. Right, this whole, I'll show you guys an after video next, where you can see the comparison without all the fume in the way, but it's all just buried in rock now. That was the ocean entry. So more recently, here's an overflight from 2021. Not exactly this year, but close enough to show you. Let's see if I go in here. I'm a little sped up, but there is that whole area, the Kapoho coast, and coming around. At a time, some very small beaches in that tidal zone. Lots of lava, but you notice not a whole lot of cracks. You really don't see a whole lot of cracks. We thought we might have saw one during eruption, Dane, at one point, but it was kind of one and done, and that was it. Coming around here,
yeah.
Is Pohoiki and Pohoiki sand, and interesting that there's so much sand at Pohoiki there. We'll talk about sand as one of the things that went in the lava, right? Coming across, here's a Malama key flow. There is 2 branches of it. The temporary road rebuilt across it that leads to Pohoiki. So more recent view of what that looks like. One thing to mention was there was that massive bloom of plankton that occurred offshore. This is from Wilson et al., and you can see here a view of measurement of that plankton bloom extending from where lava went in the ocean, and then currents bringing it offshore here. So we'll discuss this a little bit too, because there was, at the time, the research vessel EV Nautilus was over here at Loihi doing a study focusing on the hydrothermal venting, the venting of these hot fluids beneath sea level. So they actually continued mapping from Loihi all the way across Kilauea, came across and went around the whole ocean intra area. And this was in late August of 2018, so not long after the eruption ended. Actually, they still found some of the heat coming out of the flows underwater. And in fact, here are some of their scans, right? They actually show here these little plumes that they thought were worth investigating. That might have been extra heat coming off the seafloor from their what does it say here? Multi-beam echo sounder. And then over here, 3 areas at a 300 meter contour depth, maybe 1,000 feet down, where they're seeing some of this heat come up right over there, right? And then further down, they show this 700 meter contour line and that Puna Ridge going off in that direction. So the flow reached down probably around in here, this close to this depth where you're seeing this heat. So right in there. And up here in the top left, you see these red lines. That's all the different additions of the coastline from the USGS maps over time, where the flows came and extended the coastline further and further out from that original green that you see on there. So because there was all this related activity, right, new eruption to map out, clearly something in line with the mission, they diverted, went over there and mapped those flows. There is quite a lot that came out of it. What I was
the timing on that was so good. That was like a pre-planned mission and just lucked into it happening right then. Yeah, that one was. There. Yeah, we'll talk about it in the future. Maybe in about a month or so. About there was another a research vessel that came out from Oahu actually, and put out ocean bottom seismometers and other sensors to detect that water lava interaction. So when we talk water lava interaction further, we'll bring that up. But yeah, the Nautilus was conveniently located to come sweep across. So from the Volcano Awareness Month back in 2019, we pulled this clip from Dr. Carolyn Parketta,
And this is part of a larger talk about what they were addressing there. But one of the issues that they talked about, and turning to the science of it here, is like, why did that Fissure 8 lava delta not collapse, right? And so I'm going to just recap this first part of the talk here, right? During a pool era, we had lava going to the ocean. This is a temporary road in National Park, Hawaiʻi Volcanoes National Park. And you see two little ocean entries of the same flow that had come down from Pu'uo'o and split and gone across there. Now these images over here on the right, they're vertically exaggerated. They're blown up. They're twice as tall as normal, so you can kind of see the detail. But when you have this kind of lava flow, pahoehoe, going over top of these sea cliffs, it's coming in at a lower rate. It's making these smaller flows that seem to interact with the seawater more. More explosions, more debris, and you have these big debris fans that form, and that's kind of what all this lava delta ends up being built on, is all this debris that results in large part from those interactions and other collapses that makes this whole thing unstable, right? And that's why, with enough weight added onto the feature, you start forming zones of weakness. You can form cracking in the surface, which is visible. You can see here long cracks visible right there, all along that lava delta, lava bench, sometimes previously called. And when that exceeds that strength of that land, you have these big collapses, and you can have big explosions. Lava can shoot back on land, big gas clouds. You can have hot water coming on land. In fact, most of the fatalities from the Pu'uo'o era have occurred in this situation near the ocean entry. So, important thing to discuss here. So, Carolyn's gonna redraw this, and she'll talk about this. I'm gonna let her take over and talk for a few minutes here about what the observations were during that time. So, here she goes.
Wonderful, but I will note that they're 2 times height exaggerated. So I've redrawn it to be 1-to-1. And I've drawn this one from Kapoho to also be 1-to-1, so that we're comparing apples to apples here. You'll notice that at the 0 marker, which is where the coastline is, a pahoehoe delta has a pretty steep drop, and it has to build itself up until it reaches a good equilibrium spot. And it's still oversteepened here, if you notice. This arrow just implies that the current could erode some of this more fine-grained sediment and help undermine the delta. If we look at the Kapoho Bay and the first part of the delta that formed there, it's pretty darn flat. So I'm not worried about lava that filled in the bay collapsing, per se. It's not until it reaches the edge of the shelf and drops down to deeper levels in the ocean that it starts to approach this slope. But even so, on this slope, this lava flow, even though it's not off flow, is going to behave a little differently than the pahoehoe, which is oversteepened onto this slope. So I think inherently, pahoehoe might be more inclined to collapse as a delta than off flows. Now this is, we still have more work to do on this to support this, but we haven't seen any cracks form in the Kapoho delta, nor did we during the eruption. Maybe one crack, but we typically didn't see the features that we were looking for to say a collapse is coming in, who knows, days, weeks, months, but the cracks are there. The other interesting thing that we noticed, and I have some pictures on the next 2 slides for you guys, is that right here, there's a little bit of breakouts at the ocean entry that kind of does one of these pahoehoe things, and it overlaps on top of the But in general, the channel would just flow straight into the ocean. And that told me that it's entering some protected, it's protected its top somehow, that it's not interacting with the water. It's not exploding. It did on a few occasions, but fairly rare for the whole eruption. And it went out. This is a real bathymetry profile of pre-eruption and from boats who came by that were surveying. So it went out, 2.5 kilometers away from where the shoreline starts dropping off. From the edge of the old coastline. And so the thought is, where's all this material going? And many of us at HVO asked that. Where is all this material going? And why isn't it exploding when we know these little tiny things can cause explosions from Pahoehoe deltas. And so what I realized is that this is actually inflating and kind of lifting up out of the sea. It didn't do that all the time, but the next slide I'll show you an example where we did see it lift up. We saw that twice actually, and it was fairly interesting. But the point is that this is a cohesive flow as it extends underwater, whereas the Pahoehoe is just onlapping layers and layers. And so perhaps this is actually a more stable delta anyways, even though it already has a more shallow slope to begin with. Okay. This is shortly after lava entered Kapoho Bay. We're going to focus on this feature here. It's got a peak in the middle and 2 dips. So we're going to try to track that through June. Well, here we go. Put an arrow there to help. It's going to get more and more subtle as time goes on, but it's here. And I want you to focus on this next lobe that came out and formed a new part of the delta. We're going to look at what happens to the water in between these two. So in this picture down below, it's here. And then on June 11th, a few days later, it's here. And on June 14th, it's isolated from the ocean, and it's actually slightly higher in the ocean. Yes, I added the other slide. June 15th, not much change. June 22nd, it's evaporating away, and it is 1 or 2 feet above sea level at this point. So that's something that I don't think we've ever seen in the Pahoehoe Delta, where it kind of lifts up from the sea as opposed to piling on top and going into the sea and diving down. And then the last example I have of this is from July, where we were doing our routine flights. At this point, we weren't allowed to fly over the open ocean because there's such a long stretch where we had no emergency landing that we just decided it's not worth it. But this was right on the edge, and this was the coastline the day before, and then suddenly this quote-unquote island appeared. But really, this just kind of rose up. It's connected to the delta underneath. There's only a couple of feet of water here, and it's erupting lava. It's still the fishery lava. It's just come down through the delta underneath and back up. And so again, another example of something kind of rising up as opposed to piling on top and diving down. So, some possible insights from last year that we're going to keep working on for this year is that the submarine slope was shallower in Kapoho for that delta, and perhaps deltas not only grow by onlapping, but they also grow by inflating their core. So maybe this is more stable. There's some more work that needs to be done, but that's a potential interesting insight into how lava deltas work.
All right, mahalo, Dr. Parketta, for that. So just a little bit of the questions that they had scientifically after that eruption. Let's move forward to what eventually came out of that research, which is this research article by S. Adam Soul, Michael Zoller, and who we just heard from, Carolyn Parketta. Right, so this is essentially the result of that study collaboration between the USGS and EV Nautilus crew. And some highlights here. One thing that's probably the most important to people is how much lava came out on land as opposed to underwater. On land, they decided it was the land team, 454 million cubic meters on land, and offshore turned out to be 740 million cubic meters, 740 versus 454 on land. So that's 62% of it offshore, 38% on land, and a total volume of almost 1,200 million cubic meters. So big numbers there. That's like 10 times what we've seen so far in the last 3 years of eruption here. Right, so big amounts. So this is where this is, both in volcanology. We'll pull out a couple little of the excerpt images here, and I just wanted to start off by showing when they were cruising by on their way to the 2018 eruption area. They went by that Pu'o'o ocean entry area as well. And on the way by, they mapped out the seafloor, and essentially what you're showing here is a difference between the scan it did in 2018 and one it had done a few years earlier. And so at the Pu'o area, they have here marked in red areas that gained material and in blue areas that lost material. This is the area of the delta collapses of Pu'o. So you can see here the East Laiapuke area with a little bit of a blue zone where the material was essentially eroded away, right? The whole land collapsed and everything went flowing out, and all that land left here and ended up depositing, piling up over here where it's red, right? That's kind of what you see here. Other areas we had ocean entries that maybe went on for not as long, it didn't cause collapses. You see them as little red areas like that one, like over here. This might be Ka'ili area, more or less. That maybe even more slightly further east, but over there. But then another big one was Kamomoa over here, where you can see this quite large underwater scarp here, where it was scoured away, and then you can see that the lobe goes off way further offshore than any of the others, right? So interesting to note this pattern of landslides. You can have long run out landslides coming from this pool area, right? And that lower rate of lava going in, manifesting as pahoehoe flows there. So that's the first thing to know on the way by what they saw. And when I actually arrived, I did the same technique over here. So it's shown in these reddish orange colors, the differences and where you have the most accumulation there. So that those brightest colors are that most accumulation that you see. So there is that view of it. We can zoom in, a couple of zoomed in frames here. And we can look at Mackenzie area first. That's over here. That flow going into the ocean only lasted 2-3 days, maybe it was 3-4 days, somewhere in that range, right? So you do see some extra accretion here, but not a whole lot for the most part. Here's the bluish lobes, right? Didn't quite get as much. And then over here in the Kapoho area, right, pre-eruption coastline, you can see the Kapoho entry area over here, where that Kapoho Delta was the thickest, is right in here. And then because the flow actually diverted around Pu'ukapoho, Green Mountain area, and went towards the Halanui, we had a second lobe of that eastern over here, the Halanui, right? So we really have a Halanui lobe, we have Kapoho lobe, and we have the Mackenzie lobe. Those are the three main areas where lava was going in. So that's where they got those numbers from, is adding up the volumes of all those areas. They sent down the ROV, remotely operated vehicle. You can see here this little white line is this track. Went across and took some pictures and some video. Unfortunately, could not find any video, so I should show you guys some of the pictures here. You can see that a lot of the areas have a lot of rubble offshore, right? So what you see is areas where the rubble seems to be pretty well sorted. Other areas where you see it more mixed and less well sorted over here. Sometimes you have it going next to areas that have more finer sediment, like you see in a streak right in here. But when you look at these bigger boulders, you can see that they actually look like chunks of a'a flows, right? You see the little vesicles elongated within a large, dense matrix here. That's often what you see in a lava flow, an a'a flow. So an a'a flow that broke off somewhere upslope and came tumbling down here is what a lot of this stuff actually is. However, they diving pretty far deep down, 900 meters, I think, or maybe it was not quite that. I'll find that for you guys here. They find intact lava flows, where you can see that actual surface and bottom of the flow. There's a little shrimp hanging out in there, but intact down to very, very deep parts of that flow area, right in here. And because they were there not long after eruption had ended, they found this hydrothermal alteration, these yellowish spots, which turn out to be not actually anything like sulfur depositing, but iron-eating bacteria, iron-colonizing bacteria that have been attracted to these hydrothermal vents and were already causing this discoloration in certain parts of that deep flow. So let me just finish coming through the article, and I'll come back and tie up a couple of things here. They did chemical analysis on those rocks that they found down there on that seafloor, and on this plot of chemistry here, essentially you can see the pool era is right there, and then as we had progression of the eruption. We had Fissure 17 chemistries, we had phase 1, early phase 1, late phase 1, phase 2, and eventually phase 3 was this long Ahu'aila'au Fissure 8 phase right in here. As you can see that where these lines making these crosses right in here, that's the points that they found of these rocks, and so all these points essentially fall into phase 3, which is evidence that they likely came from that big lava river from Ahu'aila'au into the Kapoho Delta. So no surprise there, that's where they found it. But nice when everything does seem to line up. They took some photomicrographs of these rocks, and they actually see some interesting textures, and so to cut to the chase, what you see here is the rim of an oxidation clump, right? So essentially what you had is a glob of lava that shot up in the air from Fissure 8 and landed back in the lava channel and was carried down through the river, became part of this other flow that became part of that rock that tumbled down that cliff. So they actually can see evidence of it having been in a fountain thrown into the air in those rocks they found down there on a slope of the seafloor. So everything's all consistent here. And to tie up this paper part of it here, similar to what Dr. Parketta presented here, but summarizing maybe the key differences in what you see. One noteworthy thing is that there was no sand in much of those pictures, right? There was a layer of this kind of siltier material over top of everything, but not a whole lot of sand in those boulder fields. So here's how they have it summarized, right? Some differences. You actually have a slope with longer landslide runout lengths, right? With a shallower degree of angle, 15 to 20 degrees. Steeper angle, but shorter landslide runout lengths right there, right? Perhaps because of the different amount of lava coming in, much larger amounts of lava coming in, they were able to essentially encase and insulate themselves compared to what you saw at Pu'o. So perhaps that inflation part of it's one thing, but also that sediment, lack of that finer sediment, because when you have all that sand and you have something collapsing, it can actually help agitate that whole mass together and cause like a turbulent flow that's coherent that actually can glide farther, kind of lubricates, reduces the friction of the whole entity, right? So without the sand, you actually have a lot of different dynamics, and maybe if you have little collapses, they just kind of tumble down, and that's that, and doesn't actually cause a giant run out because you don't have that fine sediment. So there are the ultimate profiles. I think it is noteworthy, and we'll come to this again when we talk about lava-water interactions in the future, that when you have this steeper slope down, right, you can have interaction with water at a deeper level close to shore, and you can have those secondary explosions that come up. And these are rare things that occur, but they did occur. When it did happen, they were noteworthy, and there was the one that, in fact, impacted the tour boat, which is not a topic for today, but for the future as well. So that is the summary of the paper. There is one other thing that I wanted to put up here, and let's see if I can find it. There it is right there. So let's throw the final thickness map. Well, it's actually the preliminary one, but pretty close in the end. Thickness map of the eruption, and maybe I can find the final one. Let me zoom in here to the Kapoho area here, where they're actually showing 280 meters, 919 feet. So feet, not meters. I was wrong on that. 280 meters, that 300 meter area, 900 feet down, that thickest flow right in there. Let me see if I can find that more updated map, and then we'll turn to some questions, Dane, and go from there.
All right. Go ahead and take care of some super chats that we had come through. I want to thank our longtime supporter, Gary Bryan. Came through with $35 super chat. Says, thanks, Phil and Dane, for these updates. Thank you, Gary, for the continued support. And then Pardon My Piano came in with a $20 super chat and said, mahalo for the updates. I'm a pianist, but honestly, sometimes I feel more passionate about geology and volcanoes. Thank you for keeping my passion alive. I appreciate the support. I think we got some questions here lined up. Whenever you're ready.
All right, I was trying to see a final thickness map. I don't know exactly where I put it. Wait, there, final. There it is. Let's put this final map. Fill in that little blocks, but there it is. Final map. So there it is, more official. They actually show 239 meters. Whoops. 239 meters, 784 feet there is that deepest, the thickest part. All right, I'm going to clean that up there.
All right, you ready for some questions?
Yeah, let's what we got.
So Sean asks, when lava hits the sea, obviously it heats up, but water is water. How close can you get in the boat before it's dangerous?
Depends how lucky you get, how risky you're going to be, right? Ultimately.
Also, what the entry looks like, too. I mean, we were in 2018, there was times where you could just see that upwelling of water. It's like, that's not where you want to be. That's not it. Other times, I remember getting really close on boats before, but it was a different kind of flow.
Yeah, I've been on boats, been pretty close. I mean, I'd say when the lava was just trickling over the edge, the pool era,
right.
I was able to go on a boat and take both my grandmas, right?
Right.
And they got to see the flow closer right under it because most of the gas is blowing away. The gas is really the main concern. And of course, the hot water. And there's sediment, right? When lava goes in the ocean, pool area kind of fragments and forms those little sands, little floaty bits. And so you can hear them hitting the bottom of the boat and, your engines in that hot water and hitting those little rocks. So, I mean, there is impact for sure, right? And, there's limits to it. But as far as how close, there was a guy who got hit by a rogue wave and got washed. His boat flipped over and landed on the lava delta, right? Had to be rescued, right? If you remember that day, and there was at least one. I think that was the worst that I heard of it was that one, right? Where basically all he had was a life vest. He was hanging out on a beach right next to where the lava was going in, but
there was
survived.
The worst one I ever heard was not a guy that was on the boat though. It was a guy that went in on foot and somehow managed to get lost in Kīlauea for something like 3 days. Which is, if you know the area, it's kind of difficult to get lost down there. In one direction you have the lava, in the other direction you have the ocean, the other direction you have a mountain that you didn't come down. And the other direction is the way you came. Lost for 4 days.
Yeah, people can be disoriented, unfamiliar. Sometimes once you start getting dehydrated, if you don't bring enough water the first day and you just can't think straight, and the next thing you know, you're who knows where you are.
I had plenty of friends out there that they forget to put a light on their Jeep and they go out, or their truck, and they walk out and then they start going back and they're like, oh yeah, where's the car? Oh, well, I guess we're sleeping on lava tonight. And then they get up in the morning and go find the car. That's usually how it goes, type of thing, especially if there's alcohol involved back then. But yeah.
We made a good effort to always be able to walk back the most efficient way to find the car in the dark, and that was part of tour guiding, of course. Right now we weren't drinking.
Right. Okay, next question. This is a pretty good one. I sent you the link or image for this one to put up. Janelle asks, I never got an answer for this. I asked several times during the eruption. How much danger was Monalia and Hawaiian beaches in from breakouts during the eruption?
Do you want to start on this one with the map you put out, or?
Yeah. I think it would be good to show this map that I sent you.
Yeah, it's up.
To talk about it. Okay. Yeah. So this was the lava shed map that the USGS put out as part of the preliminary analysis of the 2018 eruption. And this was in about mid-July that they put this one out. And the purpose of this paper was to identify the more, the outlier cases that are that could really impact civil defense and the authorities. Even though they might be edge cases, they would, if they happened, it would be really bad. So we got to prepare for them. It was one of those kind of papers. And in it, they gave this lava shed map of, what happens if a flow comes down on the side of the lava channel and the lava channel is compromised in some way, or somehow we create a diversion. Where does the lava then go around the diversion? And this map here broke down the different areas that lava could get into. So basically what it's showing here is lava could easily get into zone 2. It ended up really not getting into it, but that would clip Nanavali. It wouldn't get into the main part of Nanavali, but it would technically clip it. And there's some houses in there that would have gotten probably seen lava if that was the case. It would have taken another one type of thing to get it into Nanavali proper. But Hawaiian Beach is kind of the same deal. It depends on where you're going to draw the lines on things. How far do you want to consider beaches? Some people don't even consider Hawaiian Shores beaches, type of thing. So if that case, it's really hard to get down. So yeah, it's basically Nanavali could have got touched,
Right.
without too much significant changes.
When this map was put out, this is the red line showing here, that's showing that current lava path. A couple of little braids here, and then it went off this way. Right, so that was the path of the lava, and by this point in time, the lava channel had been established for a while. Actually, this southern turn had been pretty recent, but had been established over here for a while. Right, this upper part never really changed much after that. But it was that kind of preparation, right? I thought it was much riskier early on. If I can pull up this earlier map, let's see here. If I can pull up map from, this is May 5th, 2018, right? Early map, one of the earliest maps that has these blue lines, these lines of steepest descent. So you can see here, we have, at this point in time, 8 fissures are open. Right through here, Eastern Leilani. They weren't really showing much flow yet, hadn't really built up much, but you can really see from that point in time, like, where is this going to go? It's hard to tell from here. There's a ridge that's right there, and then it slopes off beyond that ridge. So if it could have escape that ridge, it could have gone into these southern lava sheds, as we're terming them. But more than likely, it was going to fall into this path right here to the north, which is what we saw.
Right.
And so that one, if we follow it up, that one would have gone east of Nanavali, right? And here's that little area we'd focused on before, where it actually ended up coming across. But that would have gone east. It would have joined this other one. It would have stayed well east, and it would have gone across Government Beach Road, just east of Hawaiian beaches, as is shown on this map, right? And of course, there are other residences around here also, so that would have been impacted. That's not what ended up happening, but very, very early on, it looked like, unless the flow could actually get over to this blue line drainage area, so to speak, it was not going to hit Nanavali. Right? So early on, it seemed like, when it was a matter of who needs to worry about this right now, it was clearly it's Leilani, and not as much, secondarily Nanavali, and secondarily Hawaiian Shores, Government Beach Road area.
Right. But there was also that point in the beginning of the eruption when it was marching up, was at fissure 12 and 13. When it started, It looked like it could go back down south, across the Pali, and fall down Kalapana side. And that came really close. Like, it started to take that path, and then the fissure just dried up.
Yeah, it could have. Yeah, exactly. Anything. Yeah. Ultimately, you can see that that there, the flow that did breach out and go south. Well, it actually didn't come out of Leilani, right? It came out over here. So, in any case.
All right. Next question is from Judy S. Next eruption, say it starts at the relatively the same points, the fissures. Are these areas still considered the low-lying paths, or what would follow?
No, we would have to redraw this with the new flows on here, and the new flows are the high ground and essentially divert everything around it. So yeah, everything that wasn't covered in 2018 as low ground is more likely to get covered the next time, and everything that was covered in 2018 is less likely the next time because it's high ground. Basically, right? So if you had a flow here, the blue line gets deflected and might hug the edge of a flow. That's basically it, yeah.
Right. We now have a very long barrier that leads to Po'oiki and the coming down from the rift zone, essentially, with that giant delta.
Yeah.
All right.
Po'oiki is an area, the little depression, and there's a little drop, and the land settles there. It's a place where lava is gonna be attracted to, but it's also gonna subside again and reform the bay over and over and over. That's kind of the nature of the cycles of that place.
Yeah, there's a lot of interesting stuff with that, especially when it sinks again, which we know is eventually going to happen. It's just a matter of when. And then what does that sand do? Because that might be the thing that gets the sand out of there eventually. Is it dropping 2 to 3 feet in a day? That'd do it, or might. All right, final question here. Victoria asks, how stable is all that vast Pahoehoe Delta, that Delta shore, or did the salt water help harden the whole thing?
I'm not sure what the effect of the saltwater is as far as mineralization in there and like what that does to the strength. I really can't speak to that at all.
Right.
The whole coastal plain of Kilauea was at some point an ocean entry. So at some point down underneath all the stuff, there is some kind of rubble and all that, right? But some areas are more stable than others, right? So I mean, the areas that are essentially were the established sea cliff before the 1983 pool eruption, like that we imagine was pretty stable, had been there for a long time. That's more or less our reference frame. So most of it's pretty stable, but the stuff that still remains offshore as far as lava delta, there are areas that could still collapse potentially. But I would say that if they didn't with the 6.9 earthquake we had in 2018, and they haven't with all the other little earthquakes since then, it's probably not going to. Unless something else piles it up and changes that mass balance.
And one other thing about the the delta is it's also getting weathered by the ocean, which is incredibly strong in there. The currents are very powerful. So anything that's loose or not as solid as it can get is probably going to get torn out of there eventually, and you'll get left with some of the hardest, most resilient rock. That might end up being a sea cliff, which we see dominating the Puna shoreline until it gets to that point where it's strong enough where the process of the ocean tearing it apart, it doesn't happen so rapidly.
Yeah,
right.
So yeah, it's interesting. Yeah, and it's interesting that to bring back a point that I mentioned earlier, right? That we didn't see as much of that sand in that deeper part of the Nautilus images, but it was enough to block in all of Pohoiki. So interesting to think about whether that stuff was generated more so during eruption, or if there was less of those explosions and interaction, if it was all from erosion afterwards, or exactly what, or maybe the phases shifted, right? Maybe the sand stuff was light enough to get caught in the currents. We know that there was upwellings, the kind of tied together lava that was flowing down at 900 feet down was causing that nutrient-rich water to rise towards the surface and bring all those nutrients up. That's what caused that whole plankton bloom, right? So yeah, maybe it's separated and the sand went one way, and that's interesting because it seems like the sand at Pohoiki has stabilized and there's not a whole lot more being added as far as we can tell right now.
Right. We'll call this one the last one. We have talked about it a lot. I'm going to try and link it. I often heard, pardon my piano ass, I oftentimes heard Pahala might be the area where magma comes up from the hotspot, hence all the deep earthquakes. On the USGS maps, I have filtered the earthquakes over magnitude 2.5, I believe, and noticed that there are actually two distinct epicenter areas. We'd have to look at more data than past 30 days or so, and more precise data on that. Have you noticed anything like that? I mean, we do notice there's like trends in the Pahala.
Yeah, there's an earthquake map for the last 30 days, and you can see there, there's like that more of that kind of under the southwest rift zone, and a little bit further over, right? So yeah, it's interesting that there's a couple pathways. There's been speculation in the past that one cluster might relate more to magma feeding Mauna Loa, and one might relate to more magma feeding Kilauea, but that's just an idea at this point. I haven't seen much beyond the idea, to be honest. But yeah, we look forward to all of that, right? And really the answer to all this is going to come when they put out this summer all those seismometers all across the area, and an area to image what's going on down there. That'll be super fascinating to see what comes out of that. So we're gonna have to punt for now, and then just say that's the possible idea. Yeah, good eye to notice that for sure.
And it does show up in some old. Just pulled up some old ones, and it does seem to show. That's I'd have to look at it a little more. All right. Well, I think that does it for questions today. So we will be back next week. Standard time is 5 p.m. Hawaii Standard Time on Thursdays. Unless something changes, then we will go to you live with a breaking update. We don't expect anything right now. It's kind of quiet, but if it does, we will go live. Pass it to you, though, Phil.
Go see the volcano yourselves. This is a great time to go and see it. Things do change. It's not going to last forever. It might seem like it, and the longer it lasts, the better for as far as activity being in an area of the park where it's good to visit and it's not really threatening anyone. So we'll have to just wait and see. Yeah. But yeah, until next week, I hope you guys have enjoyed. We're closing off our second hour here, and we have a bunch more research to share with you guys next week, and there's other community stuff to talk about. So there's a lot more coming. We'll keep it flowing all summer here. So from HawaiiTracker.com, he's Dane DuPont. I'm Philip Ong. Aloha.